Hello. Um, my name is Yevhenii. I'm working as an application architect at SoftServe, and I want to say thank you for joining me today with my speech. It will be related to microservices and services testing. I keep seeing teams and projects struggling to do a proper testing for the distributed systems. So today's talk will be about building a foundation, building the getting started point, so you can go further with that later on. So, agenda for today is quite simple. There is 3 parts. The first one will be talking about the microservices in general, the test pyramid related to that. The second one is concentrated on the test types and the tools that can be used to perform the testing. And the last one is about reporting. So what can we do about managing the test execution results and what insights can we get from there. So before start testing, let's take a look at the short definition of what microservices are. Here's the definition from the Chris Richardson, microservices.io, and microservice architecture is an architectural style that structures the application as the collection of the services that are independently deployable, loosely coupled, organized around the business capabilities, and owned by small teams. So the third and the third and the fourth are good ones, but I think the most important, the crucial ones here is the first and the second, independent deployment and loosely coupled. And they both go hand in hand together. So you really cannot achieve one without another. Like independent deployment is impossible when you have really tightly coupled services because you most likely will deploy them together. And the same story for the whole system itself, right? So it will be just one single thing. So yeah, let's go further to the testing pyramid. So here is the testing pyramid is a well-known topic about the testing in general, and here is how it might look like for the microservices testing. We have the unit test, which is just unit test known to everyone, so we'll not stop here. Integration tests that testing the integration points between different services. It might be REST calls, databases, message brokers, anything else that integrates one thing with another. Next one are going component tests that testing an individual service in isolation from other ones. End-to-end tests that are really concentrate on the whole system as a unit. And on the top we have the exploratory test, which is performed basically without predefined automation or the test case. It's more like walking and trying to find out if anything is broken. And we have the fastest, the cheapest, and the most independent test at the bottom, and the slowest, costiest, and coupled at the top. So basically, with the unit test, you will get a result like in a milliseconds on the developer's laptop, but with end-to-end and exploratory tests, it's mostly even impossible to run on a single machine, especially if you have a huge scale related to it, right? So based on that, the number of the unit tests must be always bigger than end-to-end or exploratory tests, so it's going from bottom to the top. So now let's imagine systems, the huge ones like Netflix or Twitter or X, how they call them now. which has like 500 services and more, and just imagine how many integration points do they have, how many of the stuff to test. And if we concentrate on them in the traditional approach, like end-to-end test, it will be really difficult to find the issue. So let's say something's failed, how would you know that it's related to this particular integration? So here the integration test becomes a crucial. Another thing related to that, if we start an end-to-end test, let's say, in such huge environment that is really constantly changes, the team may redeploy something. You cannot hold the stable environment, not the stable, but let's say the same environment. So the end-to-end test can start in just one environment and finish in another. So to help with that problem, component test goes for the rescue. So we test the individual service in isolation from others. Honestly, the huge system like this, they are relying not only on the integration and component tests, they have much more broad set of the testing strategies to make sure that the whole system is working as expected. But today we'll concentrate mostly on the beginners layer, let's say, integration and component tests. So let's go and see it one by one. So the unit tests, as we discussed already, they're the simplest, the fastest, and the least coupled, right? So we can designate two areas or two types of those, depending on how they deal with the dependencies. One is sociable dependency, when we work with the classes, right, that have a state but less behavior, and in that scenario we're observing the test result using the state, examining the state of those classes. And the solitary, they're most like coordinators coordinating work between multiple classes. For instance, it can be a service that calls another services, that calls a repository, anything else. So for the solitary tests, we usually mock them out, right, to test the behavior for the class under the test. Next thing here is tests. Unit tests especially can be deliberated based on the balance between the benefits or value provided by the test and the cost of implementation. So the least important ones are those that test in a trivial code. So for instance, getters, setters, or the constructor that basically does nothing. It's easy to implement, but they provide almost no value, no benefits to us. So next ones coming are coordinators. The same idea, like services that are or classes that are calling a couple of another stuff and has almost no logic. The next ones is so-called overcomplicated. It might be some huge piece of code, it might be some legacy code that does a lot of work, but at the same time, maybe written not so good, but still they are really good candidate for the unit tests. And the last one is the more important, like algorithm tests. When we test something that holds the core business logic, it almost always like not so difficult to test inside that particular method or set of methods, but it provides us really high output in that. So usually it's not possible, right, to cover everything with the unit tests. So the prioritization here is the key to find the most important areas for you and concentrate on those and keep the others for later if you have time. Couple words about the tooling here. The JUnit 5 is probably the standard, right, for writing the unit tests. TestNG is still a good alternative and could be used, right? The next one is going Acer for J, so we can use really much better assertions that JUnit 5 provides by default, and Mockita is the really crucial for mocking and solitary tests, basically, to mock them out. So next going are integration tests. With the unit test, we're covering mostly the business logic, the classes that we have, but it's really impossible to cover that with unit tests, to cover the integration points, those pieces that cross the service boundaries, that require some I/O, some networking, some other stuff. So, and here the integration tests come for the rescue. We take aside the business logic and concentrate only on those integration points. If it's REST controllers, gateways, databases, message brokers, like anything in that regard. So let's start with the integration test for a controller. It might be familiar to most of you, but just want to walk you through before we go to the following ones. So the test case here is really simple. We just have a post endpoint that's supposed to create a pad with just a single field name. So pretty straightforward, sending the request, getting back the response with the created pad. But everything is mocked incept of the controller. And Spring Boot and JUnit 5 does a lot of work for us. So the WebMVC test annotation here, it's a JUnit 5 extension that basically the Spring Boot extension for the JUnit 5 that creates an Spring context for us and set up just MVC layer. So it doesn't create anything else beside that. It also uses Mockita to create a mock beans if we need some, and we still can use Afterwire to get the beans we need to. In this case, it's mock MVC, and we're using it to perform a mock calls. So technically here is not the real REST call, but it's still close to the real scenario. So lines 28 to 32 or 33, it's a Spring's way how to do that, how we can perform this call and validate the response. The next one is rest assured. It's just example. It does the same, just another way of doing that, and it may help with the further test. So if you want to have things consistent, rest assured is good enough. We'll see this one later as well. So next is integration test for the database. So integration test for the database, they're testing not only the connection to the database. The main goal is to test integration, and we may be wrong with a lot of stuff. So there might be a misconfiguration for the Hibernate, or maybe mismapping for the JPA or anything else. So those tests should help us to verify all of those issues with integration with database. At this point, we would start using test containers and Docker. I don't know if you're familiar with this, but the test containers is just really simple framework that wraps the Docker images and can be and help us to have that image running from the inside of the test. So that's why they call it test containers. So an annotation at the top, it's again extension to the JUnit 5 that registers a test containers, which scans the whole class, the whole test class for the container annotations. And here is our container. In this case, I'm using MariaDB, but it can be hardly anything. Like they support really a lot of containers for databases and for other stuff. So we'll take a look at them a bit later. So what it does, it creates this container running with the Docker, taking any random unoccupied port on the host OS so we can connect to that database later on. We can add any of the configurations, but right now I don't need anything. The problem here that the Spring doesn't know about that container. It doesn't know about what kind of port it is mapped to, what kind of credentials it is available. So service connection annotation is the Spring 1 that goes to the MariaDB container, gets all of that, and configure our context with the data from it. So it takes a URL, login, password, username, password. So it can create a real database, and we can connect to it. So the test itself is really simple. We're just testing that we can get the path, the first path from the database with some name. But the whole magic is happening here, right? So we can have a real database, a real connection to it, and another example that will be that we can inject any layer of the database integration. So we can get a bare data source, we can get JDBC connection, we can get the entity manager or the pet service to be used within the test. Also, by default, the GPA test is transactional, but unlike the real transactions in the application, instead of committing the transaction to the database, it will roll it back. So you will have really separated tests, isolated from each other within transactions, and you can run a test in parallel, and it will just work, rolling back the results. And yeah, and you can use the SQL annotation to add any data to your database before running the test. So next one is testing a REST client. The advantages are mostly the same as we had with the REST controllers, but now we're standing as a client, so we're making the call to another service. From the previous example, you probably noticed that, previous couple of slides, that we need to have the closest setup as possible to the real environment, but in this case, it's unfortunately not really possible. So if we test an integration with other service, that service might have its own dependencies, its own database, so we'll definitely end up having a huge subset of that environment, or even the whole environment set up. So for the REST calls, integration with REST services, we're using mock server. This is just a framework that stands like a Mockito, but for the REST services. Basically, we can specify the same thing, the when-then. So when the request happens, then the response will be returned, and in that case, we don't have to deal with the old dependencies. This time, Spring doesn't have the special annotation to take an URL from that one, so we have to supply it manually, and dynamic properties can be used for that. So we're taking that information from the mock server itself after the creation, and taking an random port, we can get an endpoint from it, get the URL that will be served as the URL for the notification service. And basically, the endpoint itself is really simple. We're just calling the notification email post method and expecting some results. So, by the way, here is the way how we can set up the mock server client that is connected to the mock server and help us to on the fly to configure and reconfigure the mock server. the same way technically as with Makito. So it's when and then respond. And when we do just a simple REST call, we can validate the result. And the same as Makito, we can do a verify that the only one request was happened with this method and with this path. So we can have that basically working the same way, right? A tricky point here, if we summarize the integration test, so if we have the service integration that has a lot of dependencies, then we would have to mock it anyway. If we have the end database or message broker or something that has no additional dependencies, it is much better to have the original one with the real communication. So we can test the protocol, we can test the network, we can test that this integration point is working just fine. So if you have like a gRPC or GraphQL or the WebSockets, it will look pretty similar. It will be another type of client, but it will be working the same way. So moving on to the component tests. There are two types of them. One is in process on the left side and the out of process test on the right side. So in process, they are reusing the same class path. And yeah, by the way, we're testing now the whole service. So we have everything related to one deployment unit and trying to test it. So the first one in process, we're standing inside that application as we've done with the unit tests usually. So we're using the same class path, the test itself located together in the same JVM, in the same class path as the classes we're testing. And the same thing here, we're standing inside of the application. But to not like miss this opportunity to being inside the application, the best way is to have like stub database in memory one to have the best speed possible and have an in memory in the same process stub for the REST integrations. So they are really simpler, faster, and less realistic. More realistic are the out of process. So the problem with the previous one that since they're inside the application, they're not testing the artifact itself. So technically we can implement those tests. We can test that everything working fine, but then later when we build the artifact or deploy the artifact itself may be corrupted. It might be not working or even fail to build, but when the test says, okay, we're good to go. So out of process tests, they are concentrate on the artifact itself. So they are taking the artifact that we've built and use it to verify our service. Here's the example for the in-process test. Now we have the Spring Boot annotation that basically takes the whole application running, and in the web environment, in the web container, and we have the random port assigned almost the same way as the test containers would do, but right now it's in memory still. We can use a local server port to get the port, so we know how to reach our application. And since we're in memory, right now we don't need to set up the mock server or mocking the another services communication. We can mock the client itself with Makito and go ahead. Another thing here is the after configure test database. With that annotation, the test would basically Spring will pick up the H2 database or HyperSQL, whichever you have. You may use the Hibernate after creation of the schema if needed, or even have the backups to apply for the database. Let's say database backup, and you want to apply it. test is itself is similar to what we've seen with the controller. We're just making the REST call to the post endpoint for pets to create one. But now, instead of just getting the response from it, it will also do some useful work, right? Like it will be creating that pet to the database. It will be calling the notification service to notify about the creation one. And basically for database, we have those mocked, and we have the mock for the client itself. So we can test it in the real kind of scenario. At this point, we need also verify what was created in database. And assert for JDB is similar to assert J framework, but it's concentrated on the database. So this example just gets to the table and sees that we have just one row in there with the ID one and the name that we expected. But technically, it can do much more. It can find out the difference between the database state before the test execution and after, so you can see what has changed in scope of running this test. Yeah, and Makita, as again, we verify with Makita that we had a REST call to another service. So here's the example for the out of process test. The test case is the same. We're testing the same endpoint, but the configuration and setup here is much more complicated. Here I'm using the Docker image as an artifact to test. This one, yeah. So it has been built with jib, and I'm using the generic container to make it run. But unlike the previous examples, this one is much more complicated because our container is running inside the Docker, and we need also connection to the database. So they must be able to connect with each other, and that's why we need a network created to all of them be placed in the same place technically. So that's why we use the Wiz network for all of them. The next problem that we need to have a database and a mock server created and up and running basically before our application can communicate to it. So there is depends on method that helps to specify those dependencies, and all of that has been done with just test containers. So here I have a hard-coded example for the application properties that knows the credentials and the URLs, but technically you can have a really dynamic setup because every container, when it's run with the test containers, would have a random name and the random port would be used. So technically everything could be dynamic. This time, instead of the mock server, I'm using the WireMock, another kind of framework similar to the mock server. Doing the same scene, we can specify the registered endpoint, register the result that will be returned based on that call, and doing the same thing. So rest assured here to perform the initial call to our running container, and then verifying that we have record created to database, and verify that only one call was done to the mock server, in this case WireMock. So moving forward to end-to-end tests, they are the most complicated. Now the scope of the system is the whole system as a whole, and previously all the tests that was implemented, there were like white box tests. Because we were navigating the internals, we were verifying database connections, what we have there, what we have as a result as a communication to another services. But for end-to-end test, in this case, the best approach would be a black box to concentrate only on inputs and outputs of the system, and taking the databases and internal message brokers, anything out of scope like an internal detail. So the example here that if we would have really connections and verification for the databases, then or the message brokers, that any structural change, like let's say we decided to migrate one database to another or just rename a column, right? Those end-to-end tests will require maintenance. So to avoid that, it's really the best thing to concentrate only on the input and the output of the whole system, so we don't have to deal with those. Basically, they're mimic the user behavior. Like if user makes a REST call to the endpoint and get the response, so the end-to-end test will see the same thing. If we have the UI, then the same story, navigating result to the UI response. So I don't have an example for end-to-end test, not because I don't want to, but it is really complicated to set up. So end-to-end test requires the whole environment set up. But if we would do that, technically we have the same thing that DevOps team doing, right? So they have the pipelines to have all of that running, they have environments to have the whole system, and especially if we have like even 20 or 30 services, it's really impossible. So for the end-to-end test, we need to rely on those pipelines. We need to rely on the environments, regardless they are dynamic or static. It doesn't matter, but we should have the latest version of the system possible, the freshest one, and the test itself will look the same, except of having set up for the environment. We'll just using the URLs provided to connect to some environment to perform those. One more thing, new, like usually end-to-end tests and the whole system has an integration with some third parties. And most likely, usually you probably have faced that many times. They are slow or down, or maybe providing just one environment or less environment that is required. So for end-to-end test, it's also may be a good idea to have a mock setup that mimics the integration with outside environment. It will make the test less realistic, but at the same time, it will be more reliable. So I hope you've got the idea. It was just really initial level, and there are a lot more type of the test and type of testing can be performed. But let's concentrate on the reporting part. So let's say we have a lot of tests so far. We have all those executions. We have results for unit integration components, end-to-end tests. So what can we do about this? What can we do with the results of those executions? So the first thing here is the execution time reporting. I don't know if you've been yesterday on the speech about the login with the Maven and Gradle, how slow it is. So it is slow, and from a perspective of the reporting, it's not really useful for the information. So on the right side, this is the default Gradle output, and you cannot even say how many of the tests was executed. If it was just 1 or 2 or 10 of them, it just logs, and the same thing for the Maven as well. It's more structured, but anyway. So what can be done about that? There are a couple of the plugins basically available out there. For the Maven, it's Tree Reporter supported by Maven's Surefire plugin that turns our not really interesting output from the Maven to something like this. We can navigate and see each individual result, which is really, really useful, especially if you have like 20, 50, even 100 tests. You can see the results, what was executed, what was failed, what was not executed at all. With Gradle, it is much simpler because you could have the reporting done right inside the Gradle file, but there are still a couple of plugins available similar to what we have with the Maven. We can have just a good name so we can see what's in there. Next thing is the cross execution. So when we execute, when we perform the execution or launch of the test multiple times, we could get and outcomes. What's going on with the testing? Are we getting closer to the verification, to the having the tested product, or are we getting worse? So the products like this, 6 that you can see on the screen, they help to basically see the visuals. They help to have dashboards. They have to help to have an integration with CI to approve some merge requests, maybe if you need to. Working similar as a Sonar, right, for the code quality. The same thing can be achieved here with the quality gates. They also have an integration with the tracking tools like Jira. So let's say some of the tests has failed. So the tools like that, they can they can create basically a defect for you, or they can create work items, or basically anything that makes sense to have. Also, they have the automatic regression detection. So it depends, because not everyone, but some of them have even AI. Since we have a lot of data in there, they also provide the reports and analysis based on that. We also can designate and organize tests based on the features, based on the type of the test, the service it's related to, the team. So each team can track their part of the subset of the whole test. And the last thing here is the logs and the screenshots. So when we execute something, right, like a test, we still sometimes need to get back to the logs. And if we have that inside of CI pipeline, let's say, we'll navigate that. It's not really convenient way. So here with those tools, we can have that aggregated for each execution for each individual test. And the screenshots are really helpful when you're testing a UI. When there is a UI defect and test is failed, but what exactly was wrong? So the frameworks like Selenium can make a screenshot, and it can be stored in such tools. So today we'll take a look at the report portal, which is one of my favorite, and it's still free. By the way, a lot of them are paid and really expensive, so fortunately. So here is an example how we can integrate with the report portal. Again, JUnit 5 extension with the report portal. A couple of the configuration properties. So it's connection to report portal server, the API key, the execution, the launch name, execution, and some description for that execution. Those can be dynamic based on what exactly was executed and for which purpose. The next thing what we can do, we can specify at this case ID, and that will connect us with Jira. So we would know that, okay, this test case that we implemented aligns with this Jira test case. We also can specify attributes. Those are going like tags. So based on that tags, we can designate different kind of test cases and executions to organize them. So here's how it looks like when we execute the test like this. On the report portal, we would have the test case ID, the same name, and basically a list of attributes or tags that we have specified. So, but what about logs? How we can deal with logs and images? Report portal provides an adapter, basically, that you can register with the Logback or Log4j or any other logging framework that you're using, and it will be And those logs will be forwarded basically to the report portal. So here's an example how we can attach the image if we need to. So, and as a result, we would get something like this. So we would see this upon the test execution, so we can see that the log is there, and we can even specify here the pattern that we would like to use for the test, right? So we could have the one configuration for the production, for dev environment, and another one for the test based what is more important to see here, and the image again. So the report portal, it takes the each execution, like as soon as one test case executed, it will upload it on the fly to the server itself. So some of the tools, they have report created upon the Maven execution or Gradle execution, and then you need to have additional steps to get this and apply to the tool. But in this case, right after the one test case executed, the result will be there. So you can even use it to navigate and see what's going on right now with the execution with your CI pipelines. So here's the example how it looked like from the execution perspective. We have 5 launches here. We can see how long ago it was executed, some total test, past, and others. We have a description. It's still a dummy one, but you can have a different description for different launches. So, and if we navigate to just one of the tests, we can see some more information. This particular test was executed 3 times. It was added in during the first execution, and we can see that it is green, but the second execution and fourth, they were failed. And what is important that we can see that the third execution, there is not available here. So we know that this test hasn't been executed during that time. We have the same example with logs, and the last thing important here is the investigation process. So we are, as the developers or QA engineers, depending on who is doing that, or automation engineers, they can add a verdict saying what's wrong about this test case. So maybe it was a misconfiguration for environment, or maybe the test case itself is broken. So application working just fine, but we have the test broken, or maybe application is wrong. And based on the verdict, again, the tool can communicate with Jira or any other checking tool and create for you defect for free, or add some comments or notes to the work item saying, yeah, tests are passed, so you're good to go to the next environment, or release into production, or doing something like that. So, and the last thing here, that dashboards. So this is just an example how it may look like. You may have a trends to each execution. You may have the investigation percentage to see what's going on with the failed test. You can see the build test case or the current investigation process. So for instance, here we can see that previously we have a lot of uninvestigated cases, and now we have much less of them, and we still and more no, basically it's opposite, sorry. So it was good before, and now it's worse. So we can see it, right, and deal something with that. We can see the statistic, and with the dashboards builder, we can see, we can create the dashboards and visuals that is important really for us in particular scenario. So I think that's mostly it for today. Just a couple of things as an afterward. I really encourage you to take a look at JUnit 5 features. It's not only about the unit test anymore. It provides a lot of really valuable stuff, really valuable features that can be used in your day-to-day tasks. They're really powerful. Next thing is the parallel execution. So with the unit test and the JUnit by default, we're doing the sequential execution test by test, but it's much, much faster to have the parallel execution, which can be configured just in a couple of steps. But make sure that your tests are isolated and will not affect each other. So next thing is additional testing types. I mentioned just a couple, but there are much, much more, like in contract tests, security, performance, what else? Backward compatibility tests, right? So there are much, much more of them, really. Acceptance test, and that's just a couple of them. So test case versioning, and another big topic. If you have to support the multiple versions of the same applications or the service at the same time, you most likely will need to support the multiple versions of the same test case that aligns to the different versions. So think about that in the very beginning, because that's really important. That will help you to have the multiple versions at the same time. Yeah, and the last thing is to prioritize your tests. So the more you would have, the more it will take basically to execute them. So create different test suites to verify the critical stuff, to have like a small test suite to have fast results. Create a different one for the particular feature or something like that. So that's it for today. Thank you for much.